Okay, everybody, good. What's going on here with the browser? Oh, no, that's not the browser we want to see. No. Interesting. We somehow lost our browser. Okay. All right, we're going to get it back. Don't you worry. We got the browser back. And I want to kind of talk a little bit about this information for you. Okay. Make sure everybody was aware. I did send that earlier for people. I did it for all my classes because there was a request for that, so I did. So I sent that for you guys as well. All right, so good morning to all of you on a nice cold morning, and it seems like we're late because it's the time change, right? So it freaked me out. I thought I was running late. So I don't really like that. I kind of liked when it was dark, in all honesty. I always felt like I was early. I always felt like I got an early start. It feels weird. I don't know. I guess, is it me now it's going to get dark earlier? Yeah. Like at 5 now, yeah. Yeah. Anyway, I just have to just adjust to it, I guess. Right? You just to the whatever the situation is. I don't know, whatever it's. So, ladies and gentlemen, we're getting down to this chapter 7. Historically, I did go to some of the formulas. I'm going to skip the formulas right now. I could go back to them. We'll see, but we're going to do some of the formulas. But I want to go to inverse trig functions to make sure I get some of that in. But we'll do some formulas. Anyway, inverse trig functions, I have to give you some S lecture. First, I have to talk about what a function is before I talk about the inverse function. So I'm going to give you some supplement lecture here so you guys can understand the context of what you're doing. Does anybody remember what a function is? What are functions? A function, ladies and gentlemen, I have the definition here, but I'm going to kind of draw a picture for you guys here, okay? This is in an intermediate algebra course. A scripted f represents function. But I guess I could write the definition. That's a rule that assigns every input value x, comma, to an output value y. It is. It is. I think, did I give you guys this lecture already when we talked about functions? Yeah, we have. Oh, I have. Thank you so much. Okay. That's a little bit of a review. Okay, so you say, what is a function? It's a rule that assigns every input value called x to an output value called y. So here's a picture of that machine here. I think of a function as a machine. You go, what do you mean? As a machine? Yeah, this is the rule that they're talking about. Like, what did I say to you guys before, if you guys remember? What kind of machine did I use as an example before? Yeah, you guys are right. I used the juicer example. Outstanding. Good for you guys. Good, you're right. And so X is a fruit or vegetable. This is the input. So we call that a fruit or a what? Or vegetable. And you drop that fruit or vegetable in the machine, and obviously if it's a juicer, you're going to get, for example, I always start with the apple, right? So if you drop an apple in that machine, what did you guys get? Apple juice, good. Okay, if you dropped a pear in the machine, you get, of course, what? Pear juice. Okay. These are all the input values, x, and then these over here are all the output values, y. Okay, so you're saying, wow, you're going to drop all those things in that machine? Yeah, we're going to drop again now maybe a beet. And of course, if you drop a beet in the juicer, you'll get beet juice, right? And then if I said to you guys, can you drop a rock? No. What's the problem with that? You don't drop rocks in juicers, it'll break the machine. Okay, if you guys remember that kind of stuff. So this is what we're talking about, right? There's only certain things you can put inside your functions, your machines as inputs that will give you the corresponding outputs. Change the machine, change the what? Change the situation. So, okay, bless you. So here's what we call a function, and the general notation is this: y equals what? F of x. That's the notation for a machine here. Do you know, wow, is that the famous notation for machine? Yeah, y equals f of x. And so you did see sine curves as functions, input, output, cosine curves, tangent curves, cotangent, secants, all those things. And then let's remind you guys, there's something called a definition of the domain of the function. Every function has a domain. So you might say, hey, what's the domain of a function, right? And that is the set of all input values. Okay, that's in your domain. So you say, wow, an input value? Yeah. The set of all input values, okay? So everything that you can put in this machine, like fruits and vegetables, is what we described as being in the domain of your function f, okay? So it's a set, so I'm going to do that. I'm going to give you guys some set notation. A set is a list, but we have what's called set builder notation. So the domain is written as a set of all x such that x is a fruit or what? Or vegetable. And, you know, sometimes we just say domain of the function f. This is domain of f. Okay, and this is the example associated with the machine we just described. So giving you guys the kind of cocktail party language idea behind a machine, you drop that in. And by the way, this is like f of x or y, right? Same thing, since y equals f of x. So I forgot to do that there for you guys there. And let's colorize this thing function. And that's what we're referring to. So you guys have the color coordination there, okay? Okay, now we also have something called the range of a function. So the definition of a range of your function, that's another set. You say that's the set of all output values. So that's in green. Say here's a set of all what? Output what? Values. So R here, set of all y, such that y is either fruit juice or what? Or vegetable juice. That's called the range, and we give that. Let's colorize it with the same kind of theme. X values and what? Y values. Okay? So your Y values, set of all Y values, set of all X values. So if the machine's a juicer, this is kind of how we describe really this situation that we're talking about for this function. All right, we're waking up talking about what? Domain, range. And so you might say this to me, all right, Mr. Judge, what's the deal behind all this? So I'm going to start with our first function we learned how to graph, okay? Well, let me do this. Let me go back and do this. You might ask this question here first, right? Bless you. You say, why did we call this topic the inverse function? Say, what is the inverse what? Function. What is this idea of an inverse? Okay? Now, the word inverse, it's a formal word in math. I think they should have really called it the what? The reverse function. Personally. Not the inverse function, but the reverse function. Why do you guys think I think they should have called it that? Do you guys know? Because we're going to look at the same situation, but now in what? Reverse, or they call it an inverse function. It has notation, ladies and gentlemen. You might say, what's the notation? The notation is that scripted f with the -1 power. This is not a reciprocal. This is the inverse function notation. And we're going to see how exactly that even works.
Why do you put that sign and it's not really negative?
Okay, why did they use the -1 power sign?
Yeah, when it's not.
When it's really not a reciprocal? Because they kind of, what happens in math and science, there's more ideas out there than letters to use. So sometimes we go to Greek letters. And sometimes you might say, well, okay, well, that's letters. I'm talking about this symbol. Same thing. We run out of symbols. So because they run out of symbols, sometimes they have to rehash symbols. And they can use any symbols that they like, but sometimes, like I said, it could get a little confusing if they just use any arbitrary symbol. So they're just going to use this symbol. It's actually associated with another idea in math, with an inverse, in all honesty. Like this is a inverse. It's the same concept, and there's different kinds of inverses. You can have addition inverses, multiplication inverses. Have you ever heard that idea? This is a function inverse. Yes, question.
Sir, you forgot to put the lecture or post a link to the lecture.
Oh, sorry about that. Okay, thank you. Let's do that now. Okay, thank you so much. Let's give that to these folks. It's not even awake yet. Oh, well, that makes a lot of sense. That's why it wasn't there. Okay. Didn't put the link. We'll put it now. So those people who are at home warm in bed, not a file, sorry. So if you're at home warm in bed, you might say, hey, where's my lecture? What's today's date? It's 11/6, right? All right. Thank you so much for the reminder. And those of you guys at home now, usually I double check. But I remember I double checked, and then when I double checked, I went straight to the study guide instead. Anyway, okay, now there is a link, and you'll see people pop up shortly. And I did say good morning, but that's probably why they're not there. Anyway, thank you so much for reminding me. Okay. Anyway, back to the discussion here. That symbol really comes from a more general discussion about inverses. Meaning you have for every, if you said the operation was addition, you have an inverse for addition. You know. That inverse for addition is minus a. If you said, what's the multiplication operation inverse? Well, that inverse here is a reciprocal, 1 over a. So these are just with numbers. This is now with what? A function. So we should have put that in purple because it's arithmetic or algebra, but not that big of a deal, but that's the history of that symbol. All right, so we're talking working in reverse. Now you say, what do you mean working in reverse? What we mean is we want to switch your domain and what? Range. This is like working backwards. And that's kind of an amazing idea in some ways. Working how? Backwards. Go working backwards. Yeah. So you say, what do you mean if I switch my x and y values? Switching domain and range, in other words. Okay? You want to switch the domain and your range. Now you go switching them. Yeah, so now, for example, your machine here is going to work this way. So you imagine if this were possible. As an input, x, that you drop in the machine, what if you happen to drop in apple juice? If you worked backwards, what does that even mean now? You're now going to get a what? Apple. Pear juice is now going to give you a what? Pear. Okay. What else here? If you said, what if you put in the beet juice in the machine as an input and you got instead what? The beet. Wouldn't that be an amazing machine? What else did we put in that earlier today? Imagine if you put in, I don't know, orange juice as an input, and instead the output now was a what? Orange. Okay? This is what I'm getting at. When you switch your domain and range, and you now work how? Backwards. That's what we're talking about. This here is called the what machine? The inverse machine. Working backwards now. And that's really the bottom line, okay? Switching now. Let's see if you guys remember back in, intermediate algebra, because this is an intermediate algebra topic. I remember in that class, for example, let's go back in history, right? We said recall, because we're doing a little bit of some S here. Back in intermediate algebra, functions and their inverses, I can even share that with you guys. So you say, let's go back in history here. Here, let's go to 125. Yeah, and the worksheets and videos in intermediate algebra, they are still there. We go down here to invert. You got functions and what? Inverse functions. You guys remember that? And in those days, they would say, hey, determine whether the following functions are one-to-one by the horizontal line test. Determine the inverse function for the following one-to-one functions. There was a process. And so back then, I used to ask people, hey, determine that inverse function. That's what we're talking about, ladies and gentlemen. You say, are there inverse functions in trig? Yes. Now you might say, okay, well, what's going on there? Well, I'm going to take the sine curve. And a lot of times, we write the sine curve here. All right, sine curve, okay. And generally speaking, oops, if we go to Desmos, let's see. Oh, I got some Desmos work here. I'm going to get rid of that, that, and Desmos. We say y equals what? Sine of x. Okay, here's a nice sine curve. And I'm going to bring that into our lecture just to kind of go over the details because the devil's in the details. All right, you guys, here we go. Add to existing note, inverse functions. Okay. All right. You got a sine curve. And if you guys recall from intermediate algebra, even in that worksheet, if they ask you what is the inverse, how do you get the inverse function, right? You're going to say you can't. Does anybody know why you can't? This does not have an inverse. Thank you. Oh my God. Thank you so much. Remember this? Sine is not 1 to what? It's not 1 to 1. You go, how do you know sine is not 1 to 1? It does not pass the what? The horizontal line test. In other words, the horizontal line test, right? And that's what I'm looking at here. You got the horizontal line test hitting your curve at this picture, since sine is periodic. We look at this, and you're hitting that horizontal line, hits the curve at like 4 spots. And when it does that, you have an issue. That means it's not 1 to 1. It fails the horizontal line test. Okay, you guys remember that in 125? I took a parabola, drew a horizontal line, and you go, oh, you can't find the inverse. All right, fails the horizontal line test. Okay, but we have a solution. Does anybody remember the solution here that we did back in intermediate algebra with like a parabola? There was a solution that we had to do. And you say, I don't believe you. Yeah, like in question number 19 and 20 and 21 and 22, 23 and 24, those are all parabolas. They're not 1 to 1. And it says determine the what? The inverse function for the following 1 to 1 functions. Oh, I apologize. They are 1 to 1. And you say, how did you make them 1 to 1? What did we have to do? It's right here. See this? It's right here. It's right here. What did we do in intermediate algebra to make those functions 1 to 1? It's right there. It's right here. Yes, we had to do something called restrict the domain. So you said restrict the domain? Yes. We had to restrict the domain in such a way that you made your functions 1 to 1. This is called restricting the domain. You did it here in questions 19. If I can kind of move that here. Yeah, make it center stage. We did it for questions 19 2. Oh, I guess I have to go back here. We did it for questions 19 to 24. All those domains were restricted. For x being greater than or equal to 0, for x being greater than or equal to 0, for x being greater than or equal to -4, for x being greater than or equal to 0, for x being greater than or equal to 0, for x being greater than or equal to 1, we restricted the domain, ladies and gentlemen. To go through the details here, okay? So now you look at this and you say, Mr. Judge, how in the world are we going to restrict the domain now for sine? Well, we're going to restrict the domain for sine to be values of x that are between negative pi over 2 and positive pi over 2. Yes, we're going to throw some values out. And if we look at this picture, you might say to me, well, what does that even mean? We're going to restrict the domain this way. This is where negative pi over 2 would be. And this is where positive pi over 2 would be. Okay, we're going to only allow those values of x to be between those two numbers. And what that's going to do for us is that's going to give us a sine curve that just looks like this. I'm going to share with you guys that. And you go, it's going to just look like that? Yes. So let me do this. Let me copy this now. And bring this down here. And I want you to consider this function now. Oh, let me copy. Okay, well, I'll write it down again, I guess. We're going to restrict our domain. And you say we're going to restrict the domain. Here's the restricted domain now. Okay, that's an important detail. Okay, we're going to restrict that domain now. We're going to tell Desmos, okay, Desmos, this is how you restrict the domain in Desmos. You put the bracket, and now we got to put negative pi divided by 2, less than or equal to x, less than or equal to positive pi divided by 2. Okay? And let me do something too. I'm going to, your y values would be, let's say between negative 1 and positive 1. Oops. X values. Delete between negative 2. Anyway, see if that looks a little better. Doesn't look much better, but okay. All right. I'm going to import this in. Okay, there we go. And now what you guys are looking at is what? The sine curve, this portion of the sine curve between negative pi over 2 and positive pi over 2. What's so important now is that this is now what? 1 to 1. You say, how do we know? By the horizontal line test. So you now have a 1-to-1 function by the horizontal line test. Okay? And so now we can actually do what? Find an inverse. So, does anybody remember back in that class, intermediate algebra, there were steps. First step, let y be f of x. Well, it's already described that way because sometimes they'll just give you the f of x notation and say, here you go. Here is the function, f for function. It's a sine function with a restricted domain. Now it's 1-to-1, passes the horizontal line test. I guess we have to really draw a horizontal line first. Okay. There we go. Now it's horizontal. And it hits the curve in exactly one spot. Curve's 1 to 1. So you say, okay, let y be sine x. And you say, okay, here it is. Y is sine. This is our inverse function process, if you guys recall. Step 2 is the key step. You're supposed to switch the x and what? Y values in the process. That means you say x is sine of what? Y. So here's the inverse function. This is the key here. Switching x and y, like we did, gives you now what? Switching domain and range. So in intermediate algebra, we did this. Step 3, you say, what's the step 3? Solve for y. And it's solve for y really using algebra. And that's the procedure so far for finding your inverse function so far. And so you say, okay, I got to solve this for y? Yes. Using algebra? Yes. And you guys know what's the problem? There is no algebra that you can use to solve for y. And you say, what? There's no algebra that I can use to solve for y? No, there's none. But you know this has an inverse because it's a one-to-one function now with its restricted domain. So the inverse does exist. So you might say, well, why do I look in back of the book? Or why do they now say, okay, you just solve for y, and they put this notation? And I'm going to say because they cheated. That's why they did it. They cheated. They pretended to solve for y, but this is where that inverse sine curve what comes from. Pretty in pink. And then, sorry, that's not even step 4. That's still step 3. Step 4, if you guys recall, was to say now that you solve for y, they say let y be the inverse function notation. And so formally, you know, if you said, is the inverse function for sine going to be what this is called? And the answer is yes. And so, you know, this is the complete 4-step process of finding inverse functions back in intermediate algebra and even in pre-calculus. So you found it. So this is the birth of the inverse function. And so by definition now, ladies and gentlemen, they'll define the inverse function always this way, okay? They go back over here in step 2, really step 2. This is logically equivalent to saying, okay, right in here, when they switch x is sine y, they jumped here, y is inverse sine x. Okay, we're just talking about that portion here. Yeah, and I'm going to give it to you. So here's the formal definition that you guys will always see in every book. It goes back to that step 2 always. It's really step 2, step 3. Okay? So if you look in your book, they're going to call it this way. Definition. The inverse sine function is the following. They put the notation, sine with that -1. They'll put the inverse sine of x equals y is equivalent to simply saying sine y equals x. I actually rather write it this way, okay? Y is equal to inverse sine And this is where they get the definition of inverse sine. But this is the key over here. Okay, this is the key. Do you guys happen to know what this symbol is? The double arrows? I'm going to do it a little bit better. This comes from geometry. That means equivalent to. So this left sentence for inverse sine is equivalent to what you guys see here. That's the meaning of that double arrow, equivalent to. And so you might say, what are they talking about? They're really talking about step 2 and step 3 when you switch the domain and range. So remember, you switch domain and range, x and y values. Is that right? So we switch the domain and range. And what that means now, okay, is your inputs for inverse sine are going to be between -1 and 1. And the outputs will be between -π/2 and +π/2. Because you switch your domain and range. You go, what are you talking about? Yeah, these are the x values. These are the y values. The same x values over here, the same y values over here. When you switch them, change them, you made the function 1 to 1. And this is, remember, these are all my x values. They're now y values. They switch. So your domain and range are now opposite. So I'm going to move that down here. Move this up here. And now we're going to answer the question is this. Does this have a graph? And the answer, ladies and gentlemen, is absolutely. Because you're now switching the x and y values like we did. You're looking at this function now as its own function where the input is x, the output is y. Your inputs are going to be between -1 and 1, and the outputs are between -π/2 and +π/2. We're going to see this as its own function. In other words, we think of this as f of x as well. This is a new f of x. It's a function. It's in the family of functions. Behaves like functions. And it has graphs where x is horizontal and y is vertical. And I'm going to import the graph for you guys because I'm going to use Desmos again. I'm going to tell Desmos, hey, Desmos, y equals, let's see, it should be here. There we go. Inverse sine x now. And I'm going to change the color. I don't like to use red for this. I'll use blue. And get rid of the black. And I'm going to change the x. It's too, for me, it's just too, what? Narrow. This is a lot better. And I'm going to take a picture because this is the inverse sine curve. I'll put it here maybe, see if it comes out. Yeah, I guess we'll leave it like this for you guys. And this is, ladies and gentlemen, the graph of your inverse sine curve, but this is where it comes from. So I spent a lot of the morning going over some ideas in intermediate algebra, some S, to now share with you guys where this inverse sine comes from, where this is now your x values. On an x-axis, think of this inverse sine as its own function. These are the y values, and that's the inverse sine curve. It's only defined for values of x. This is now my domain. between -1 and +1. The values of y, the output values, are going to be here. pi/2 and -pi/2. So I'm going to have to label them. Let's use blue. +pi/2 up here. -pi/2 down here. And all we're saying, these are now my y values. Domain and range, ladies and gentlemen. It's a new function. So now you might say, how do we use this? Right? So here's our inverse function. Okay, what do we do now? How do we use this? They're going to now tell you guys, evaluate. Huh? What's that? They're going to say, evaluate something like this. Inverse sine of 1/2. And then you go, how in the world do I get inverse sine of 1/2? Okay, you have to follow a process. All right. How do we evaluate inverse sines? Now, I'm going to say this to you guys here. Notice this. Go back over here, okay? Remember, sometimes we like to see this x as theta. And this is theta in radians, real numbers. So sometimes, ladies and gentlemen, that x we know as theta. I'll leave them both here, x-axis, theta axis. So we do see that. So sometimes we say, hey, are angle theta between -pi/2 and +pi/2? Yes. And you might say, is that going on here? Well, y is now that theta because we switched domain and range. So what I like to do when I do this is you follow this process. You say you can say let y be inverse sine 1/2, but sometimes I just say let theta be what? Inverse sine 1/2. You guys with me on that? Now, what is that equivalent to by definition here? You see why I say y or theta? That's equivalent to this statement here. So whenever you see your inverse sine equal to something, you're going to use this part. This is what you really use. Now that means sine theta equals what? 1/2, because in that definition, this is the x value, this is the y value, this is x. In the definition, this is still x and this is y now. Because you're using what again? Sine y equals x. It's equivalent to the statement they gave you. They're equivalent to each other. So now we are happy. You say, why am I so happy? Because I'm going to ask you guys this question. What is theta? We have to get theta. Now, how do we get theta? There's two ways, right? Well, let me just go back. How do we get theta? Where does this come from? Do you guys remember your right triangles? Well, they're back. How do you guys get theta? What's the definition of sine? That's what? Opposite over what? Is it opposite over adjacent? This is 1 over what? 2. This is going to be, ladies and gentlemen, yeah, opposite over hypotenuse. What is theta? So that is what we're going to have to focus on. And the good news is you guys already know how to what? how to do that. That's why I gave you this happy face. Here's going to be the big question for us now. What is the special triangle associated with this? Do you guys know? Is there a special triangle? We have a hypotenuse 2, opposite is 1. There is. This side is a square root of 3. Is that right? Anybody remember? What special triangle is this? It's a 30 what? 60 what? 90-degree special triangle. How do I know? I recognize it this way. Do you guys remember? What is theta? Anybody remember theta? Go back to your special triangles. You only have 2. Is theta 60 or is theta 30? Theta is 30 degrees. Is that right? And that means theta is what? Pi over 6. Because theta is the angle right here, right? $60 degrees would be here, and this whole thing is 60. Remember that? So theta is 30 degrees. So it goes back to your 2 special triangles, ladies and gentlemen, and that is important for us. So now I would say to you, you've answered the question. If this equals theta, like we said, and we found theta to be what? Pi over 6. Is that what we got theta to be? Yep. You're done.
Sorry, but where do we get the 1/2?
Well, the definition, it was given.
Oh, yeah.
Inverse sine is 1/2. So, ladies and gentlemen, you answered the question. Easy peasy, lemon squeezy. There it is. What is theta? It's pi over 6. Easy peasy. Now, you say, where is 1/2 at? Well, 1/2 is somewhere over here, but anyway, I want you guys to also be able to use this here. What about the TI what? Calculator. You go, TI calculator? Yes. Do you guys remember your calculator? If I said, let's wake up the calculator, okay? I got to wake up the TI. So I'm going to have a few seconds here to wake it up. Where's the TI at? There we go. So, in your calculators, you guys know you have inverse sine keys? Right? Let's take a look at the mode. Your mode here is what? Isn't that in degrees? Okay. All right. Now, where's your inverse sine? Here, it's blue. So if I said second inverse sine, 1 divided by 2, what do you think I get? 30 degrees. It's in degree mode. You guys with me on that? Now, I'm not saying for you guys to do this. What I'm saying really is they're going to give you other questions where it's not a what? Special triangle. When you have special triangles, I want you to go back and remember the definition of sine and your special triangle, like you did here. That's why I put a happy face, because you guys already know how to do that. You want to know how to do this. But they're going to go to a place now, and you say, what do you mean? Why did you just show me the calculator, even though it worked here? They might give you inverse sine of maybe 0.652. There is no special triangle that you'll have here. And then you say, what do they want me to do? Use your calculator. You guys see what I'm saying? So there's gonna be questions where they're gonna say to you, hey, try this out, inverse sine 0.652, and guess what? This is about 41 degrees approximately. There is no special triangle that will give you that 41 degrees. You guys with me on that? So I just want to make you guys aware from the beginning that yes, the TI or any calculator can do inverse sine just like it could do sine. But that's where it comes from. So now you guys know all the details of where this inverse comes from. It's really working in reverse. And they're going to give you more questions, like, for example, for inverse sine, let me go to your book. They may say, here's another evaluate inverse sine here. Okay. But theta now, you say, what do I do? Let theta be inverse sine square root of 3 over 2. And what does that give you? Sine theta equals the square root of 3 over what? 2. Okay, so the second they give you this evaluate an inverse sine, use the definition we gave you guys, and then now say that's the same as sine theta being what you have here. And then get very, very happy. Why? Opposite over hypotenuse. Say, why do you get very happy? Because, ladies and gentlemen, what do you guys have? The square root of 3 over 2. What's the special triangle? Do you recognize it? This has to be what? 1. Say, wait a minute. Have I seen that before? It's still the 30, 60, 90 triangle. But now, what is theta? See, what I see is this. What is theta going to be now? What degree is theta going to be? Now it's going to be what? 60 degrees. And what is 60 degrees as radian measure? Pi over 3. So this is what you're going to have to do. Get pi over what? 3. Okay, so this equals, this is what? Pi over 3. And this will equal pi over 3. Easy peasy, lemon what? Lemon squeezy. Now you say, Okay, what about my calculator? Well, guess what? Second what? Inverse sine square root of what? 3 divided by 2. Does that give you 60 degrees? Sure does. Okay, you guys okay with that? Easy peasy, lemon squeezy. All right, let me do a few things here. All right, now let's give you guys another example here, okay? You say, what if they tell us to do the following? Say, what if they give me to evaluate negative 1/2? Or let's start off with the one we just did, negative square root of 3 over 2. Okay, what's the process again? I say, let theta be what? Inverse sine now of negative square root of 3 over 2. Okay, you guys okay with that? That should be pink. That means sine theta is negative square root of 3 over 2. All right, you guys okay with that? I want you guys to think about this because this is what's going to come up. This is what's happening here. This is an important detail. Where is sine negative? Yes, go back. I'm going to bring it in. Let's think about this. This is going to be a great detail. Anybody remember this? What's this? All students take calculus. Where is sine negative? Huh? I think it's quadrant. Let me highlight it. Quadrant 3 and quadrant what? 4. Is that true? You guys with me on that? So there's 2 locations. But if I go to my TI and I say, hey, TI, second inverse sine, I'm going to scroll out because I want you guys to see this, at least in a TI calculator. Some of your calculators have that minus. Don't use subtraction. Use the square root divided by 2. And you say, Mr. Judge, it tells me negative 60? What? Why am I getting negative 60? Why do we say theta has to be negative pi over 3? Anybody know? Because this is important. I'm going to do this. I'm going to cross out quadrant 2, quadrant 3. And I'm going to use it with highlighters instead because I want you guys to see it. And I want black. Where's black? Highlight. It's really gray, I guess. Why did I throw out those quadrants? Why is quadrant 3 and quadrant 3? Why is there not a quadrant 2 or quadrant 3? Go back over here in your definitions here. This is something that you don't want to overlook. This is something you always want to remember, okay? You see the range here? Negative pi over 2 to positive pi over 2. Where did it come from? It came from the sine function. What do we have to do with sine to make it 1 to 1? We had to restrict the domain. Is that true? You know what that even means? How do we restrict it? We have to have it defined for negative pi over 2 to positive pi over 2. Right in here. You know what that means? This is quadrant 1, and this is quadrant what? 4. When we threw out x values, we actually threw out quadrant 2 and quadrant 3 because we can only have sine be defined for negative pi over 2 to what? Positive pi over 2. Negative 90 degrees to positive 90 degrees. So there is no quadrant what? 2 or what? 3 anymore. You restricted your domain. And that is a detail people really need to know about. Because sine is now only good for quadrant what? Quadrant 1 and quadrant 4. But you have negative angles. It was based on the restriction. So down here, this is why you're going to get that negative value here. So you say, Mr. Judge, how do I really do this now? Okay, get the reference angle. Remember that? Your reference angle is the quadrant 1 angle. You got to go back to that reference angle, and that now means the reference angle is the positive what? The positive sign, because it's quadrant 1. This is always your point of reference. A positive angle. So when you draw your triangle now, this is important, it must be that quadrant 1 positive angle. Opposite over hypotenuse. Yes, it's a special triangle where this is going to measure 60 what? Degrees. And that's why we say pi over what? 3. So that angle for the reference is right here. However, what's the story? This is a negative sign, and sine is negative in quadrant what? Quadrant 4. You just have to describe it now this way. Go back down, negative what? 60. So this is a negative what? 60 degrees, or we call it negative pi over what? 3. So there's one quadrant where the function will be positive. The other quadrant, the function's negative. And for inverse sine, you do allow for negative angles. And that's why your TI calculator said what? Negative 60, ladies and gentlemen. You see my point? You threw out some quadrants. That's the bottom line. So let's do the process again, but now for negative what? 1/2. Share with you guys how that works. Sine of negative 1/2 now. So I'm going to want you to evaluate, get the exact answer. Inverse sine, negative 1/2. Let's see that process now. So step 1, again, you say let theta be inverse sine negative 1/2. Then what does that mean? Sine theta is negative what? 1/2. Okay, so you're going to say, use that pink definition. Well, from the pink definition, we always use this. I wrote that in your definition. And then you go, but this is negative. I know, go to the what? Positive quadrant 1 answer. So you're going to have to use that positive. That's the reference angle. So this angle here, opposite over hypotenuse, this is square root of 3. This is a special what? Triangle. You guys okay with that? It's a special triangle. Okay. What's the angle theta then? What's the reference angle? 30 degrees? Okay. And what's 30 degrees in terms of radians? Pi over what? 6. Okay? But that's not your answer. You say, that's not the answer for inverse sine is negative 1/2? No, let's go to the calculator. Remember this? Oh, sorry. Let's go to the calculator. Scroll out. Second inverse sine negative 1 divided by 2. You say, Mr. Judge, it gives me negative what? 30. Why does it give you negative 30? Because back here, the positive angle was 30 degrees. You found that reference angle. But sine is negative. And so you're going to have to go down here, what? This is 30 degrees here. This is negative 30 degrees, negative pi over 6. Because the original question is what? A negative sign. So this is why you have to get the reference angle. And then remember that detail. That this will be a negative what? Pi over 6. There's your answer. And that's the process, ladies and gentlemen. What do you guys think? Easy peasy lemon squeezy? So, what if they said to you guys to do the following? To use calculators. They'll say, what's inverse sine now of negative 0.127 here? Okay, they're going to want you to use the what? You say, Mr. Judge, why would they want me to use the TI for this? Because there won't be any special triangles to be able to use. You only have 2. Everything can't be 30, 60, 90. You didn't do the 45 degree, but we will. But here's my point. Now, you have no choice but to use the what? The calculator. Second inverse sine and negative key down here in this one. 0.127. Close that up. And you go, what is this in terms of a degree? You could go to the nearest thousands. It's negative 7. Well, you go to the nearest whole number. It's not even a whole number. It's an integer. So you can say, is that negative 7 degrees approximately? Is that true, ladies and gentlemen? Now, you could be more accurate. I think the book has it more accurate, but I just want to share with you guys the TI has questions there too. We actually used this when we did law of sines, the ambiguous case. We have used inverse functions, but today you guys learn about where that comes from and why you can do that. Do you guys remember that? Using your calculator for this stuff? Well, here's the good news, ladies and gentlemen. We also have inverse cosine and inverse what? Tangent to do. We're not going to do it today. We're going to do it when? Tomorrow. So welcome back on a nice, sunny, cold morning where you get to use inverse signs today. And I'll put some homework in Canvas for you guys, okay? But let's take a look. Maybe I'll do it now. Yeah, I'll kind of do it now. Look at this. Okay, we'll probably have you guys work on 1 to 12, and that's 7, 4. So let's go over to Canvas. We'll enter it here. We're going to do the formulas, just not right now. 7.4. We're going to start at 1 to 12 all. And make sure you guys have that there. And we'll see you guys tomorrow, okay? Take care, stay safe. Have a wonderful day. We talked about inverse what? Sine, inverse functions. Inverse sine, right? Working in reverse. So we did it in two ways. We found the exact value where what happened? We did not use any calculators. So there was no calculators involved with the exact value. That's what that means. And then we did use calculators. Is that right? And we approximated to the what? Tenths. And also I'm going to say to you guys, just as a note, your answer is in degrees here. So let's give the answer here in degrees. Okay? And these answers we're going to give in what? Radians. You should be able to see what's going on there. So all of these are warm-up questions. We're going to do what today? Get nice and warm on a nice cold what? Day. Cold morning. It's not really that cold, is it?
It kind of is.
Well, it's LA cold, so in other words, life could be worse. But anyway, let's get nice and warm anyway, just in case you're cold. We'll give you some time to try this out, and let's see what happens. All right, ladies and gentlemen, here we go, here we go, here we go. So let's take a quick look on this and go back and see the process. You guys remember? So here's the process you guys will employ today. Number one, right, what you say is you let theta be inverse sine of 1 over the square root of 2. Is that true? Okay, and then you use the definition of inverse sine. That definition says sine theta equals 1 over the square root of 2. Is that right? All right, you guys okay with that? All righty. Okay, so ladies and gentlemen, here we go. I want you guys to know this here. This is an important detail, okay? That this is a positive answer. Is that true? Now that's good. You want to go back and remember the definition of sine here, right? We're going to call this theta here. And what do you guys know about sine? Isn't this what? Opposite over what? Hypotenuse? So they're saying the opposite side is 1, the hypotenuse is the square root of 2. What you guys have to know is this. What special triangle is this? Anybody remember? What special triangle is that? That's going to be the 45 degree, what? 90 degree special triangle. Is that right? So what does that mean about your angle theta here? It means theta is 45 degrees, but they want that in what? Radians, okay? Now, here's the deal. Does this kind of make some sense? Let's go back and let's think about this, right? Remember, this sine curve is defined for what? Over the restricted domain from what? Negative pi over 2 to what? Positive pi over 2. Is that right? Isn't that what this is defined for? Negative pi over 2 to positive pi over 2? And you say, well, what does that mean? Well, let's go back. And remember, we're going to input that picture here. That the sine curve is right here. Right? These angles, negative pi over 2 to positive pi over 2, is essentially quadrant what? It's these quadrants here, over here, right? Quadrant 1 and quadrant 2. You're throwing out, quadrant 1, quadrant 4. You're throwing out quadrant 2 and quadrant 3. Those are gone. So that the angle is pi over 4. Is that right? Okay. So, ladies and gentlemen, let's go down here. It looks like we're good because in quadrant 1, sine is positive, and in quadrant 4, sine is negative. Is that right? So here's our answer, pi over 4, ladies and gentlemen. And that's what they're looking for. Okay, anybody have any questions on this one here? That's all the gory details, ladies and gentlemen. Now, look at question 2. You say, how does question 2 relate to question 1? They want sine of negative, inverse sine of negative what? 1 over square root of 2. Okay? So we're going to approach it the same way here. You're going to let what? You let your theta be the inverse sine, and then definition of inverse sine means sine theta becomes what? Negative 1 over the square root of 2 here. All right, you guys okay with that? All righty. So I want to warn you guys the following here. That this is a negative what? answer. That's negative. So because that's negative, in theory, what you would say at this point is you'd say, you know what? I'm going to have to answer the reference angle question. The reference angle is the quadrant 1 angle. This is quadrant 1. So you always go back to that reference, and quadrant 1 is right in here now. And what you found by the previous question was that this is really pi over what? 4. Is that right? You guys okay with that? But that's not what they're asking. They're asking for a negative angle. So this actually tells you something here, right? What does it say? It says that this, in quadrant 4, sine is negative. So what this means is that reference angle here, this is going to be pi over 4, but it's going to be a negative angle here. Okay? Because that's where sine is negative, and this is defined for negative angles. So we're in our restricted domain again. So that's okay. So your answer here now is going to be what? Theta is going to be negative what? Pi over 4. And that's the difference. Okay? You guys okay with this idea? I wanted to give you guys an opportunity to compare and contrast. Compare and contrast.
So the domain is between pi over 2, negative pi over 2 and pi over 2, right?
And positive pi over 2, yes. So your domain, just to kind of reiterate and say, what does that mean? Your angle is negative 90 degrees to positive 90 degrees. Negative 90 to positive. Negative 90 to positive, okay? Negative 90 to positive, and you say why, because this is what we're saying here, right? You say why, because remember in the first place, what did you guys need to be 1-to-1 and have an inverse? We needed to have a what? We needed to restrict the domain. There we go, all the way back here. You had to restrict the domain and use the horizontal line test. There's that restricted domain so that you can have a 1-to-1 function so that you have an inverse sine. And so you can't even have an inverse sine unless you restrict that domain. And that was the domain restriction. So that's the idea you're going to use whenever you have negative angles. And that's kind of what we worked on yesterday. Now, the last 3 are really easy. You go, what do you mean the last 3 are easy? Right? You see the last 3 here? Let's take a look.
Wait, what was the last oh, it was negative pi over 4.
Negative pi over 4. Yeah, so make sure that's a negative pi over 4. So if I said to you guys this, go back here to this picture here. Right? And what I'll do is I'll move it here. I'll draw it myself. I won't use Desmos. Because what we're looking at, again, is the sine curve with that restricted domain between negative pi over 2 and positive pi over 2. Is that right? And sine, positive 1, negative 1, looks like this. There's that theta, there's that y if you want to look at that, right? So for question number 3, it looks like for 3, they now say, hey, we want you to look at inverse sine of 0 now. Okay, so use your definition. That means sine theta equals what? 0. Where is sine theta 0? Well, I have been preparing you guys to find intercepts for sine. Where is that going to be? Theta equals what? 0. So you just answered the question. That means theta is what? 0. 0 degrees if you want to have that, or 0 radians. So that's when theta is 0, you get sine is 0. That's the meaning of the intercept. That's what we've been asking you guys over and over again. So this is what I mean. In order to look at this picture for 3 and even 4, question 4 is done the same kind of way. Right? You let theta be what now? Inverse sine of 1. By definition of inverse sine, that means sine theta is positive 1. I've been preparing you guys over and over again. Where is sine positive 1? Yeah, right up here. You guys remember? That's where you have the max. Right? This is where sine is positive 1. See that right? It happens when theta is what? Pi over 2. Easy peasy, lemon squeezy. Question number what? 5. Let theta be inverse sine of negative 1. By definition, sine theta will be what? Negative 1. So if I ask you guys now, where is sine theta? Negative 1. That's where you have the minimum here. You guys remember that? You guys remember the minimum? That happens when theta is what? Negative 1. So if you guys can see what I have done, if you've done your homework on graphing for sine and cosines, I've asked you all of these questions here, right? Where are the intercepts? Where are the max and minimum values? We've located them. These are the answers you guys use for inverse sine as well. Okay, you guys okay with that? Easy peasy lemon squeezy. Okay. 3, 4, 5. All right, ladies and gentlemen. That brings us to inverse what? Cosine, okay? Inverse cosine. Anyway, okay, so here's what I'm going to talk about. So let's talk about cosine, ladies and gentlemen. And generally speaking, for cosine, if I go over to Desmos again, like I've been doing, We say, okay, what does cosine look like? Here's generally your cosine curve. Is that right? So you say, oh, Mr. Judge, there's cosine. And what do we know about this? By the horizontal line test, if I just write down, y equals maybe 1, and I color this maybe red, okay, by the horizontal line test, what's the deal there? Doesn't it fail the horizontal line test? Fails. So it's not, doesn't have an inverse cosine. So then you might say, okay, Mr. Judge, can I restrict the domain? Yes, you can. But this time when you restrict your domain, ladies and gentlemen, you're going to restrict it this way. We have to restrict the domain to make it 1 to 1. So we're going to restrict it this way. 0 less than or equal to x less than or equal to pi over 2. Is that right? Sorry. I guess let's go pi. There we go. So we're going to restrict it to being 0 to pi, really. And now, ladies and gentlemen, what do you guys notice about the cosine curve? It's 1 to 1. Thank you. All right, so what I'm going to do now is this. I'm going to take this into Desmos for us, because we're going to take that picture and we're going to use that. And I'm going to bring this down, all the way down. Okay, so you say, how did we restrict this? Cosine is defined now from 0 to pi. This now makes this 1 to 1. So I want you guys to know this is a restricted domain. And I got to move it down a little bit. Oh, sorry. I want you guys to know the y values, by the way, are between -1 to 1. So we have domain and range, so that when we switch this and give you the definition now of inverse cosine, right? I'm going to give you the same definition we had yesterday, or the same process yesterday, if I can. Do this here. Sorry. Okay, so give you guys a definition now. The inverse cosine. They'll say y is inverse cosine of x is equivalent to saying x is cosine y, where you switch domain and range now. So your x and y values, ladies and gentlemen, are going to look like this. So remember, this is the part that we find useful here. This is the part we really use. And we use it in the context at times where you say, oh, theta. Okay, oops, sorry, y is that theta value, not x. Okay, so we're going to use the same process here. But I have to show you the inverse cosine curve as well in Desmos. This is the definition for inverse cosine. And it's found the same way we did inverse sine. So if I go to Desmos and remove this and this, you say, can you show me really in theory that inverse cosine curve as well? Sure. There it is. Let's change the color. I guess let's have another color. Yeah, we could use black. And then I think I'm going to make it a little bit whiter. There it is. Yeah, it's going to be inverse cosine. All right, hold on here. Import this, done. This is your inverse cosine curve. And I'll even do this for you guys, just so you guys know. Do you guys know, what are we even talking about? Because you go, what are you talking about, Mr. Judge? If you were to graph this function here, is what I'm saying. That's the graph of inverse cosine. Does anybody happen to even know where it comes from? I just want you guys to recall something amazing here. Go back to intermediate algebra. What do you want to recall from intermediate algebra? What's the relationship between any function and its inverse? Like if I showed you this, this is the inverse cosine curve. Do you guys know the relationship between those functions? I'll show you in Desmos. Here's my point to you. You might say, Mr. Judge, what's the deal with these two curves? I'm going to remind you that if you go back to the algebras, you're looking at something very important here. Right? You say, what are we looking at here? That's so important. Do you guys happen to know? What we're looking at that's important is this, the relationship between y equals cosine with that restricted domain from 0 to pi in purple, and the graph of the inverse function, y is inverse cosine. They're symmetric about the line, y is x. That was a relationship between any functions and their inverses. So this is the idea behind all of that, where this comes from. And I'll put that even in our notes here. It's in the video that we'll use for the rest of our lives, right? These videos. To share that with you. Hey, what happened? Oh, there you are. So just to kind of give you guys that historical perspective with this graphing, because, you know, I didn't mention it yesterday, but I'll mention it today. The purple curve, I didn't get all of it. Is that right? Did I? Let's go back and delete that cut. Hey, we said cut. There you go. Okay, let's try to get it all. Okay. Create new note, add to existing note. So I do want to give people details. You guys do want to know those details. Okay, so in purple, if we recall, this is that f function. In black is the inverse function. In red, that line, y is x. What we're saying is, in purple, every one of these points here on that curve, these coordinates, x and y, they got switched. So if I switch my x and y values, what you're going to see, ladies and gentlemen, is everything's going to be on that black curve here. Okay, so that point, whatever that point is, 2, and maybe down here, negative 0.5, would be negative 0.52, becomes up here, because we switch the x and y values, right? So I just want you guys to see this purple location, whatever that was, is switched. Every point on that purple curve has their x and y values switched, and they're going to be now on that black value, that black curve. You're switching this. This is the line y is x. So this is what we have from, I should say, the algebras, or intermediate algebra, that the relationship between a function and its inverse is reflected about that line y is x, and that's where this curve for the inverse cosine comes from. So I just want to give you guys that historical idea behind this so that you guys are complete with your knowledge, and you go, hey, where does that inverse cosine curve come from? Well, the restricted domain of cosine, this curve, and it's reflected about the line y is x, every one of those points.
To get the inverse of that, right?
Yeah, to get the inverse function, yes. So then I do want to show you guys another important picture here. About this here. You know this restricted domain that we have you look at here? From 0 to pi. This is something we're going to have to remember as well, right? What quadrants are those? It's quadrant 1 and quadrant what? 2. This is a different function. So what went out, what we threw out, ladies and gentlemen, is quadrant what? 3 and quadrant what? 4. Those are out. Easy peasy lemon squeezy. Those are now out and gone. So that's going to be a factor when we work with these examples here. Now you say, what do you mean it's a factor? Well, let me give you guys an example here. They're going to find the exact value again. This is how we use it, the same way we did inverse sine. They can say, okay, what's inverse cosine of 1 over the square root of 2 now? Okay, find the exact value again, and they want it really again in radians. The process is the same. You say, what do you mean? Well, you're going to let theta, the angle theta, be what? Inverse cosine, 1 over the square root of 2. That now means cosine theta is 1 over the square root of 2. Okay? Okay. Now, you might say, well, what do I do? Well, you're going to have to remember, this is good. You say, what is good? Isn't this nice and positive? Isn't that positive? What's the definition of cosine? Adjacent over hypotenuse. So, the adjacent side is 1, the hypotenuse is the square root of 2. You're back in that situation when they say, what special triangle is this? Exactly, ladies and gentlemen. It's the 45 degree what? 90 degree special triangle. What's the angle here? It's 45 degrees, which makes this pi over what? 4. Now, here's our answer. Okay, here's our answer. But I want to share with you guys again to go over this important detail that you don't want to overlook. Remember now, your domain for cosine is between 0 and what now? What's the restricted domain? 0 and pi, is that right? 0 and pi. 0 and pi. So this is your restricted domain, 0 and pi. You threw out, so that everybody knows, quadrants 3 and quadrants 4. So in quadrant 1, your reference quadrant, cosine's positive. In quadrant 2, cosine is what? Negative. So this is all defined only for those two quadrants. Okay? So, in other words, that quadrant 1 angle is perfectly fine. We're done. This is our answer. Pi over what? Pi over 4 here. Now, you might say, what happens if they give us, to compare and contrast, cosine of what? Negative what? 1 over the square root of 2. What do you think happens with this one? Anybody want to tell me? You go through the same process. Now, again, you're now going to say what? You always say let theta be what? The inverse cosine of this. Use your definition of an inverse function. Cosine theta is negative what? 1 over the square root of 2. You guys okay with that one? And I'm going to point out to you This value is negative. Is that right? So in theory, you do the same process. You say go to the what again? Go to the reference angle, the quadrant 1 positive angle, and you'll say we already did that, but we're calling it the reference angle now, where this gives us pi over 4. See the last example, right? This is what we did prior for the positive answer, but now it's a reference angle. And you say, why do I have to see that quadrant 1 as a reference situation? Because again, this is where cosine's positive. They asked us where cosine is what now? Negative. It's not a negative angle. Where is it going to be? Do you guys remember? Isn't this the reference angle again? That's a pi over 4 reference angle. So what angle is this going to be? What's your answer going to be? Do you guys remember how to get that? How do you get that? Theta is pi 180 minus what? The reference angle. Do you guys remember? Let me go back with that formula. So theta is pi minus that reference angle. And that's why we have to find that reference angle here. So our calculation says, let's do the arithmetic. Pi minus pi over 4. Can you guys do that arithmetic? Isn't that 4 over what? 4? So now that means theta is going to be what? 3 pi over 4, ladies and gentlemen. It's a quadrant 2 angle. This is why you need that reference angle, pi over 4. So this is 3 pi over 4 here. So we're going to say, okay, we know this equals what? 3 pi over 4. Do you guys know what degrees is that? Isn't that 135 degrees, by the way? It's 135 degrees. Is that right? So what if you said, can I do this in my calculator? Let me go back because our calculator is not even awake yet. Let's do that in our calculator just to kind of verify. So you say, here you go, second what? Inverse cosine negative. Oh, you guys may not have that. I think I'm scrolled way too in because I want people to see every detail. So I'm going to try it again. Second cosine negative 1 divided by square root of what? 2. Let's come out of there and close this. What do you think we end up with? 135 what? Degrees, because the calculator is set to degree mode. You guys see my point? So my point is, if it's inverse cosine, there are no negative angles. They're all positive angles. I'm going to say that again. There are no negative angles for inverse cosine. They're all positive because the domain is restricted to be 0 to what? Pi here. Okay, for cosine, to make it 1-to-1, invertible, so inverse cosine exists. This is the definition. So, you know, we can do that as well.
So no negative angle for cosine.
Not for cosine. Mm-hmm. So, okay, ladies and gentlemen. Let's try this again now. Let's have you guys try some. Right, you go try some ourselves. Find the what? the exact values. In other words, that just means no calculator. Inverse cosine square root of 3 over 2. Inverse cosine minus square root of 3 over 2. Or, yeah, we'll try that. Inverse cosine of 0. Inverse cosine of positive 1. Inverse cosine of negative 1. And they'll say use the what? Calculator. Inverse cosine of maybe, oh, what? 2.16334. We'll give you guys some time, and of course, we'll go over it, okay? Same thing as before, though. Give you guys some time here. Okay, should we try these out, ladies and gentlemen? Now, they want us to find what? Notice what the language they're using. Find the what? Exact values. No calculator here. So, the first two are related, aren't they? You say, what do we mean? Let's try this out. At least get the first two in, right? We're going to let theta be what? Inverse cosine square root of 3 over 2. Then by definition, we say cosine theta equals what? Square root of 3 over 2. Okay? So now what we'll say here, oops, we lost. There we go. Here's theta. We notice that this is nice and what? Positive, is that right? But what's the definition of cosine? Adjacent over hypotenuse. So this will be square root of 3. Hypotenuse is 2. So what is the opposite side then? 1. This is a special what again? It's a special triangle. That's the whole idea. So what special triangle is that? 30, 60, what? 90. Okay. So what angle does that mean this has to be? Is that 30 degrees? And then 30 degrees in terms of radians is pi over what? 6. So ladies and gentlemen, your answer will be pi over what? 6. Easy peasy, lemon what? Lemon squeezy. You guys okay with that? So if they said to you now, okay, well, find the what? Find the negative answer. Same procedure. Let theta be what? Inverse cosine negative square root of 3 over 2, which means cosine theta is negative what? squared of 3 over 2. You know that this value is what again? Negative. So what that means is you're going to have to use the what? The reference angle, and that reference angle is the quadrant 1 angle. You already know from the prior example that the reference angle is pi over what? 6. Right here. Is that true? However, this is cosine. And if we go back to that nice picture, okay, if you guys recall this. See this pi over 6 value? Well, cosine is actually negative. What quadrant is cosine negative here? Remember, you got to get rid of quadrants what? 2 and 3. Cosine is negative in quadrant what? 3 here. No, sorry, quadrant 2. Okay, quadrant 1, the reference quadrant, that's where your cosine is positive. So you say cosine's positive here, and cosine is what over here? Cosine's negative here. So pi over 6, ladies and gentlemen, yes, was 30 degrees. So the angle here, the quadrant 2 angle, is pi minus the what? The reference. Is that true? So this will be pi minus pi over 6. So do your arithmetic. 6 over 6 means what is theta? 5 pi over 6. And that 5 pi over 6 again, remember, right? Here's the picture of it. You got the reference here. Pi over 6. But that means your angle, though, is what? That 150 degrees. That's the theta. 5 pi over 6. And that's what they're looking for. So this equals what? 5 pi over 6. Isn't 5 pi over 6 150 degrees? So if you even check with your calculator, second inverse cosine negative square root of 3 divided by 2, close that. Ladies and gentlemen, don't we get 150? And that's exactly what we're saying here, because this is 150 degrees. So that picture is worth 1,000 words. This is how you answer those questions. We'll continue when? Tomorrow, and hopefully you guys are started on your homework on this, because we're going to talk about inverse tangent. And there we go. All right, take care, stay safe, have a wonderful day. And there it is. So, ladies and gentlemen, let's go over this, okay? I think we didn't do these, did we? Do you guys remember? We did the others. We didn't finish these. So let's finish it so you guys can be able to answer those kind of questions. So remember, we're going to start with this first one here. Let's go over finding inverse functions. They want the exact value. You guys remember the exact value? So you're going to say, okay, let theta be what? The inverse cosine of 0. Use the definition. And what that means now is cosine theta equals what? 0. So we're going to want to find where cosine theta is 0. Now, undo. What I want to do is go back over here. Go back to your cosine curve with the restricted domain. Okay, right in here. And I'm going to get rid of that. And you might say, we restricted the domain for cosine to be between 0 and pi, right? So where is cosine equal to 0? That's another way of saying, where's the what? X-intercept. Good. And the x-intercept is where? Right there, pi over 2. Okay? So I want you guys to remember, we're looking for here. This is why I even asked you guys on the graphing to tell me, ladies and gentlemen, where is cosine 0? That's the x-intercept or theta-intercept. If they call it x or they call it theta, that axis, here's your answer. Okay, so let's find it. Theta is pi over 2. Okay. So, ladies and gentlemen, easy peasy lemon squeezy. There's the answer for theta, pi over 2. Okay? There it is. Okay, you guys okay? Anybody have any questions on that one? That's how you answer the question. Yes. You don't graph it. They just, what's the instructions? It's determine the exact value, and that's the exact value in radians, by the way, okay? This is radians. Now, we're going to do this one, inverse cosine of positive 1. So now, we'll say this. Let theta be inverse cosine of 1. By definition, I mean cosine theta will be what? 1. And so we have to find, where is theta 1? Remember, theta is 1. That's where you have what we called a what? The maximum value. Is that right? So we're looking for theta to be a maximum value. Cosine theta is 1. Where is that going to be? Where is theta? Right? Cosine theta is 1 right here. So that happens when theta now equals what? 0. Is that true? So there it is. Theta has to be 0 in order for cosine to be 1. And let's see if I can bring this here. So that's all they're saying here. Cosine, this is 1. There it is. Oops. 0. Cosine theta is 0. Okay. Easy peasy lemon squeezy. Now cosine theta is negative 1. Okay, same process. You're going to let that theta be cosine, inverse cosine, right? Theta equals inverse cosine of negative 1. Use the definition of the inverse cosine. Cosine theta is negative 1. This is where cosine has what? A minimum what? Value here, right? You want it to be a minimum. So it's a minimum, negative 1. It's right there. So where, ladies and gentlemen, for what value of theta or x do you have cosine being negative 1? Do you guys know? It's right up here. What is it? Pi. Outstanding. theta is what? Pi. When theta is pi, ladies and gentlemen, cosine theta is -1. There we go. And there's your answer. That's what theta is going to be. Theta is going to be what? Pi. Okay? What do you guys think? Now, what do they say with this next one? The last one. Remember, we didn't get to this yesterday. They want us to use a what? Now they want us to use a calculator here. So this, by the way, we say, okay, let's look at the details behind this, right? How you start that is the same exact way. We say let theta be the inverse cosine of 2.1634. And so now they say, okay, cosine theta is going to be what? 2.1634. So let's wake up our calculator. For me, it's a TI calculator. And remember, if we're going to use this calculator, what I want you guys to note, put that in your notes, I want you to use, well, use degrees. Okay? Use degrees. So what that means is you got to go to the mode on your calculator and set it to degree, and I see that it's already in degree. So I'm going to quit that. So now, oh, I apologize. Let me go back here. Let me go back. Yes, we're trying to answer that question, but we don't even need this because we're using the what? You're using your calculator. You don't need that. So I apologize. We're using the calculator. So let's see what that is. Second inverse cosine, we say 2.1634. Close that, and what do we get? You get an error on this. You go, what? There's an error, and the answer is what? Yes. Why? That's right. Thank you. Good job. I'm going to put this as a note. Why is there an error in the calculator here? Say error? Yes. So if we did use that definition, I want you guys to remember this here. Here's the fact. That cosine will always be between -1 and +1, just like sine. And so using the definition like we did earlier, we're saying cosine theta is 2.1634. I will say to you, this never happens. So you throw that out and you go, what? Never what? Happens. Can't happen. So if they give you this, you go, no, not a good deal. Can't happen. Easy peasy lemon squeezy. You guys see my point? So I just want to share with you guys that, because sometimes in the homework, they might do that to you and you get an error. You go, boy, I looked at my calculator. I got an error. I might be doing something wrong. Nope. You just have to remember that cosines live between -1 and +1. It could never be outside that. So if we had to do another example, and now they say, okay, 0.576, and let's put another value, 8, and they really want to know what is theta using your calculator again. Okay? Well, we can say here theta equals the inverse cosine 0.5768, which you guys will see, you'll get an answer now in your calculator. So clear that out. Let's see if, well, let's get to the calculator, sorry. Okay, so you had an error for the first one. So we're going to say second inverse cosine now. This would be point what? 5768. Close that. What's your answer? Do you guys know what you're looking at? What is that answer? Yeah. And you might say, what are my instructions? Well, let's look at the instructions. What if they say to you guys, approximate to the nearest whole number? Approximate to the whole degree. That means theta would be approximately, look at the calculator. They're saying the 4 is in the ones position. The digit to the right's a 7. What does that mean I do to the 4? Add 1. Is that right? And that's going to be now what? 55 degrees. So, ladies and gentlemen, there you go. Yes?
So what if it doesn't say approximately the whole degree?
Yeah, you might say, what if it doesn't say that? That's a very good question. If it's blank and it doesn't tell you by instructions, and you go, I don't even know, that's a good question. Well, here's generally the thing. You're looking back at the answers and see where they approximated. You might see they approximated to not the whole degree, but the what? What if they say, hey, approximate to the 10th of a degree? What if that's your instructions again? And now you go, well, what digit is in the tens position, right? What digit's in the tens position? Well, the digit to the right of that decimal is the tens. So that first 7 is in the tens position. So you look at the digit to the right of that, which now means this is a what? 54.8, yes. So you guys are correct. It means 54 point what? 8 degrees.
How would we answer this on the test? Like, is it maybe a whole number or?
Whatever, whoever writes it will have to tell you. Is that terrifying? It's following instructions. Is instructions terrifying? Are you the kind of person that you get your Xbox or a VCR at home, you never read the instructions, you don't know how to set it up? And you spend a whole hour trying to set it up, and then you realize I better read the instructions. And they says, I got to do this, and I forgot. Do you guys see what I'm saying? That reminds me of the whole VCR thing. So they will give you some instructions. Try to read them. In fact, when I give you the revision, I actually made that clear in the revision. This is why I'm revising. I go back and look at it and go, oh, got to change this and take that out and revise it. And you go, oh, okay. This is why I remind you guys of, you get revised study guides, and hopefully you guys are hooked into Canvas and you follow those instructions. Woo, instructions are important, ladies and gentlemen. Instructions aren't scary. Instructions are your friends.
They're only scary when they don't really instruct you.
That's scary to me, is if they don't instruct you.
It's like they would instruct you on how to answer the question, but how to
Right.
write the answer.
Right.
So much harder than it should be.
Well, like I said, in all honesty, for me, what is scarier is the lack of instructions. And then you go, well, how do I handle that? Well, you kind of have some freedom. I hate to say it. If they don't give you instructions, you got freedom. And so you might do tenths, you might do the whole number, because they didn't instruct you. And I remember as a student myself, in those days, I would go back and look at the answer. They go, oh, they did the tenths. So I said, I better do it in the tenths. I understand that. Oh, it's in the tenths. Oh, if I look back in the book, oh, they did the hundredths. Oh, they did the whole number. It's kind of how we looked at it. But yeah, It's a very common question. This is why I had to rewrite a lot of worksheets for other classes. When I used to get the worksheets done by publishers, okay, they used to not have any of those details. And I always had students complain and go, I don't know where to put my answer. And so this is one of the reasons why I redone some of those and put those instructions, so now I don't get those complaints. I don't get those questions. Some of these other things. But anyway, that's the deal, ladies and gentlemen. So, your calculator's your what? Your friend. So anyway, that's the instruction thing. And I think you're right. It is scarier without any instructions, personally.
So we have freedom.
Then you have some freedom. And the problem with freedom comes what? Responsibility. And that's where the problem, that's the freedom thing, Some people just can't be free. Why is that? Because they're what? No, I just think, with freedom comes responsibility, a lot of responsibility with freedom.
Yeah, this question is why,
It's a philosophical question, right? Isn't that really philosophical? With freedom comes responsibility. That's why sometimes some people think freedom's bad, because there's a lot of irresponsibility. And that's why some people think take away the freedom. And some people say yes, great. Some people say no, oh no. It's a philosophical thing. Anyway, all right, ladies and gentlemen, that leaves us to our last inverse tangent. And you guys know the drill. If I go to Desmos, you might say, boy, in Desmos, where are you, Desmos? Oh, that's not for you guys yet. Let's go look at tangent. And you go, wow. And I'm going to choose blue this morning. And you go, boy, look at tangent. Mr. Judge, that is not one-to-one. Yeah. I think I use that one. Let's back up. You guys see this here? What am I trying to say to you guys? Tangent, which is periodic, is not one-to-one now, is it? So it doesn't have an inverse. What do I have to do to make sure tangent has an inverse? Restrict the domain. Good. And so here's the standard restriction. It's going to be restricted from negative pi divided by 2 less than or equal to x less than positive pi divided by 2. And what you guys will notice now is tangent is nice and what? One-to-one now. So I'm going to import that here into Notability. Okay, so tangent is now what? One-to-one. But let me give you this picture here so you guys remember this. And I should have done it. Let me see if I can still do that. Okay, go back to this since we're going to graph. I'm going to get rid of this picture. I'm going to give you guys another picture. I want to make sure you guys know this here. I'm going to put our vertical asymptotes Do you guys remember the graph of tangent, the fundamental graph of tangent? There we go. You guys know what I just gave you guys? What's this location here? This is location. I'm going to put all these important points. That's the location of our what? Vertical tangents here. Okay? Trigonometric functions. Sure. Okay. Now the function's 1-to-1. It's a 1-to-1 function. It has an inverse. Notice we threw out some quadrants, though. In order to do that, we kept some quadrants. You might say, what quadrants did we keep? Do you guys know what quadrants we kept? We kept, oh, that doesn't look good. Right, what quadrants did we keep? We kept quadrant 1. You say, where's quadrant 1? It's all of these values from 0 to pi over 2. Is that right? It's all these values from 0 to the vertical asymptote. Pi over 2. And we kept the values, negative values. Oh, we're back to negative values. That's quadrant 4, by the way. So I want you guys to see that here. Quadrant 1, 2, 3, quadrant 4. I'll bring the all students take calculus. You go, all students take calculus. Let's bring that picture in. And what I'm saying to you, in order to have an inverse trig function, we threw out quadrant 2, quadrant 3. You say, really? Because you have now what here? From negative pi over 2 up to 0, that's quadrant 4, negative angles. And 0 to pi over 2, that's quadrant, ladies and gentlemen, 1. So let me share with you guys this here, okay? I'm going to get this ray and say again, just like inverse sine, you're defined from negative pi over 2 to what? Positive pi over 2. Negative pi over 2, positive pi over 2. Negative pi over 2, positive pi over 2, ladies and gentlemen, because all means tangent is what? Positive in quadrant 1. The C in quadrant 4 means cosine's positive, which implies your tangent will be what? Negative. So in one quadrant, 1, tangent's positive. In quadrant 4, tangent's what? Negative. You threw out quadrants, what? 3 and 4, by the way. So you might say, okay, what's that definition again of an inverse tangent now? Well, they're going to say again, y equals inverse tangent of x is equivalent to the statement x equals tangent of what? Y. And again, like before, this portion is what we use. We use that portion, meaning that's going to be our theta again, theta again. So here's again the definition of inverse tangent. Okay? And I have to give you guys a note here. Originally, this is our tangent curve. So originally, tangent is defined from negative pi over 2, okay, to positive pi over 2. We don't include those values because we have vertical asymptotes. You guys are looking at what I'm saying right here. And your y value, wish I could move everything. I guess I can't. All right. Your y values are all real numbers. Negative infinity. Okay, so this is for your tangent curve. Boy, that looks bad. I think I'll just do this. Okay, I get to move it around. Maybe. Okay. What else? Oh, this is a 2. Okay, so you restricted the domain. Inverse tangent comes along again, and you go, okay, everything switches. Just looking at the inverse tangent curve, you guys have to know this as well, by the way. The inverse tangent as a function switch domain and range. So you have your x being between negative infinity and positive infinity, and the y value between negative pi over 2, positive pi over 2, because remember, you switch domain and range. This is an inverse function. The graph of that function, thinking of it as a function, has its own graph. Its own graph in Desmos, you guys can see it here. I'm going to do this here again for you guys. That y will be, there we go, they have inverse tangent. And I'm going to get rid of the vertical asymptotes. And I'm going to keep this here. What happened? Oh. Yeah, I got to change this scaling here. There we go. Anyway, I'm going to get rid of this tangent. And now you're going to have y being pi divided by 2. And another y being negative. Let's color it red. Okay, so here's what I want to say to you guys. The vertical asymptotes now became what? Horizontal asymptotes. And that's because it's reflected about that line y is x again. I don't think I was able to. I mean, I could show you guys again with that. But I want you guys to see that this curve here always is what? Add to existing. Note, this is your inverse tangent function. It's a function in and of itself. Okay. It's a function in and of itself. That's your inverse tangent curve. That's when you switch every x and y value. You switch the domain and range, okay? And so that gives us, this is where the definition comes from for inverse tangent. Right, that's the whole idea. So this is kind of the information. This is everything spread out for you or determined for you so that you guys can now evaluate inverse tangent here. Because they're going to say again, in this case, find the what again? Find the exact values. And again, that'll be just in radians. And I put things like without using your what? Calculator. That's the whole point. So, for example, inverse tangent 1 over the square root of 3. Right? So you might recognize all of this and you go, oh, okay. You start with the same process. Let theta be what? Inverse tangent 1 over the square root of 3. So you're going to start there like you've done all of them. And now what I say, this is kind of what they're saying here. This is your theta. Oops. Yeah. I got it. Let me hold on. This is your, I got it backwards. Sorry, guys. This is your theta. Theta. You guys with me on that? That's where you start. This is where they say, hey, let's get the right colors there. That's the theta. This is where you start, okay? So theta is inverse tangent of the number. And so using the definition now means tangent of theta will be that 1 over the square root of what? 3. So just like before, what do you guys want to think about? You want to go back to asking yourself the question, what is the special triangle? You only have 2. It will be. Because what's the definition of tangent? Opposite over what? Adjacent. What's the opposite side? What's the adjacent side? What is the hypotenuse then? Do you guys know? 2. So we're back to what is this special triangle? There's only 2. All right. What's theta? Anybody want to tell me? What I see in my mind always, 1, 2, this will be what? 30 degrees, and that is pi over 6. So the answer for theta is pi over what? 6. So that's all you have to say. Easy peasy lemon squeezy. Theta's pi over 6. Now, what if they said to you, okay, if you guys remember, what if they said, what's the exact value now if it's negative 1 over what? What about now? What if they ask you for the negative? You know how they do that, right? What do you guys say now? Well, you let the process be the same. What's that process? You let what? Theta be what? Inverse tangent negative 1 over the square root of 3. By definition, tangent theta is negative 1 over square root of 3. What do you guys use again? You guys have to remember this. If it's ever negative, you go, wait a minute, go to the reference angle, go to the positive version. And you would do that process here, even though you don't have to because you know the answer. Say opposite over adjacent. It's a special triangle. We know the reference angle is pi over 6. 30 degrees. This, I'm going to go through the whole process, right? Because quadrant 1 is your what? Reference quadrant, always. But that's saying this angle has to be what? What was it? Pi over 6? 30 degrees? There it is, 30 degrees. So now, ladies and gentlemen, down here, negative what? 30 degrees, or negative what? Pi over 6. So you're going to have to use the reference, ladies and gentlemen, because tangent is negative. It's not positive. They gave you a negative tangent question, not a positive tangent. You see that there? So we need theta, and so theta will be simply what? The negative pi over 6. And there it is. Isn't that exactly what we did with inverse sine? The answer is yes. It's exactly the same as inverse sine. So, you know, ladies and gentlemen, I'm going to have you guys try some yourself, okay? Find the exact values. Now that you guys know how to do these things, right? Inverse tangent of 0. Square root of 3. Inverse tangent of minus square root of 3. Inverse tangent of 1. Inverse tangent of minus 1. Okay? So I'm going to do this here. Let's see if I can do this here. Find the exact values. Use your what here? Calculator. Inverse tangent of and we'll say go to the nearest what, and you approximate whole degree, I guess. Okay, so you're going to use your calculator here, ladies and gentlemen. Let's get out the what? Let's get out our clock. Let's see what you get. Okay, are you guys okay with this? Did you guys get some of these done? Okay, let's try number one. All right, so number one here. Let's see what we can do. We're going to let what again? Theta be inverse tangent of 0. Let's see if you guys can see this here, right? So for number one, by definition, that means tangent theta has to equal 0. Is that right? So far, so good? That's the definition. Go back to your tangent curve. What are they asking? That's not the tangent. That's inverse tangent. What are they really asking? They're saying, where is our tangent equal to 0? They're asking us for the location of what? This intercept. That happens, this is that theta. That happens when theta equals what? 0. That's an intercept. Is that true? It's the location of your x-intercept. We were asking you for intercepts when you guys graphed sines, cosines, tangents, right? So there's your answer, ladies and gentlemen. The answer is theta equals what? 0. Easy peasy lemon squeezy. All righty. What about number 2? Square root of 3, inverse tangent. Good. Okay. All right. Number 2, we say let theta equal inverse tangent of the square root of what? 3. Then what does that mean? Tangent theta equals what? Square root of 3. Okay, you guys okay with that? So far, so good? Okay, now I'm going to say to you guys, what you want to do is put this as a fraction and use your definition of tangent being opposite over what? Adjacent. What's the opposite side? Square root of 3. What's the adjacent side? 1, and then the hypotenuse is 2. Easy peasy lemon squeezy. All right, folks. What special triangle is this? Theta is, this is a what? 30, 60, 90, is that right? What is theta? Theta is going to be what? 60 degrees, which is known as pi over what? Pi over 3. Anyway, there you go. So number 3, though, they're asking for, notice this, compare and contrast, right? What if they say, what's inverse tangent of minus square root of 3? Minus number 3 now. Inverse tangent minus square root of 3. So we're going to let theta be what? Inverse tangent minus square root of 3, which means tangent theta is going to be negative what? Square root of 3. Now, because this is negative, right? We have to go to the reference angle. And we already know that that reference angle is pi over what? Pi over 3. Is that true? But that's the reference angle. That's not theta. That's the reference. So go back over here to that picture of all students take what? Calculus here. Okay, if your reference angle is pi over 3, which is 60 degrees now. Because remember, right, here's the reference angle. Pi over 3, because quadrant 1, what's the deal with quadrant 1? Right, what's the deal with that quadrant 1? Pi over 3. All right, you guys good with that? All righty. But tangent's negative, so that means we have to go what? We have to go negative what? Negative. So this will be negative pi over what? 3. Okay, because you're going to have to use that reference angle. So it's a negative pi over 3 value. So ladies and gentlemen, you're done. Theta's negative pi over 3. There's your answer. Easy peasy, lemon squeezy. Theta's pi over negative pi over 3. Okay, number 4, ladies and gentlemen. Let's look at number 4 here. Number 4 is inverse tangent of 1. Number 4. Inverse tangent of 1. So we're going to let theta be inverse tangent of 1. And now that gives us what? Tangent theta equals what? Positive 1. So we're back in that same situation we just seen, right? See this original 1? Or number 2? So we're going to do the same thing. What do I mean by that? Put this over what? 1. Now you have opposite over what? Adjacent. Believe it or not, if this is 1, this is 1, what's the hypotenuse? Good, Pythagorean theorem. What's the special triangle? Yes. You guys see what I'm saying? So all of these exact value questions, and I shouldn't say all, Most are going to be to use a special triangle. Not all, though. And so that's why they say the exact value. So what is theta going to be? Pi over 4. Outstanding, ladies and gentlemen. See this here? You can do that. So easy peasy, lemon what? Squeezy. Okay. It's number 4. What's number 5? Inverse tangent of -1. You guys might be able to figure that one out. What is that one? Inverse tangent of -1. Okay, you're going to let theta be that. Which means tangent theta is what? -1. And if it's negative, you guys know the drill, right? You go, oh, okay. Oh, let's get the right colors. So you know the drill. You have to go to the positive version, and you know that angle is pi over 4. Is that right? Which makes your final answer for theta be simply what? Negative pi over 4. Easy peasy, lemon what? Squeezy. Is that true? You guys okay with that? So far, so good? What do you guys think? It's okay? So, ladies and gentlemen, here's what I'm going to do. I'm going to let you guys go right now. We'll finish these tomorrow, but you do have homework and a revised study guide. I say take a look at that and work more on those questions. You should be able to do most. We'll see these calculator questions tomorrow. So have a great day. Take care. The calculator work, okay? So, you know, I did do a final revision, so we contacted you and informed you. And ladies and gentlemen, here we go, okay? All right, so let's do the calculator work. Okay, and so they say, let's approximate this to the whole what? Degree. So remember we mentioned yesterday, right? When they're specific, we follow the instructions, and we're happy because they gave us instructions, right? We do get a little bit stressed when they don't give us instructions. I understand. Then we get confused. What do I do? But then that means you have a little bit of freedom then because they didn't give you instructions. But if you look in back of the book, then you compare and you go, oh, they did it to the tenths. They just weren't as thoughtful. And sometimes that happens. It just happens. So I understand because I had the same issues when I was a student too in math, and I would look and go, what do I do? I wish they were more thoughtful. But I try to be thoughtful on your test so you guys can read it. And, you know, that's my idea. Yes?
So with the test, is it possible that you just write 2 answers?
Sure, it's possible, but you want to, but if I say whole degree, you want to do what? Whole degree? If you have freedom, then you choose. You could put a whole, or you could put a tenths, or you could put hundredths, you know, if you have that kind of freedom, you know. So then they give you that choice. So anyway, and yes, of course, on your test, I do have a what for you guys to use. I'll send it to you as well this weekend. I'm going to send you guys a, what is it? A trig cheat sheet type of thing. You guys know what I'm saying? Formula sheet. I'm going to send that to you. All right. So you guys are aware of those kind of things. Anyway. Okay. A trig cheat sheet you're going to have. You don't bring it. I provide it for you. A nice clean one. Okay, so I have updated the cheat sheets for you guys as we go along, and then you bring that, and then I'll give that for you on your test. So anyway, All right, let's try this out. So if I go to the TI, okay, we're going to have to find the inverse tangent key. And in my calculator, it's in blue. So I hit second inverse tangent, and then I'm going to put that 0.2563, okay? So you might say, what did I just do? I'm using inverse tangent, and I entered this, what? This value, okay? So now I hit enter, and this is 14.375. So remember, this is in degrees. Is it? Well, how do we know? Let's double check. You go hit mode. Yes, it's in degrees. Okay. So this is approximately 14, because the decimal, you know, is there. Look to the right, it's a 3. So if it's a 0, 1, 2, 3, or 4, we keep it the same. So it's 14 what? Degrees, ladies and gentlemen. So I just want to let you guys know, we'll use the pink highlighter. I don't know what color. I don't know, purple. Well, we've been using purple for algebra. I'll keep purple algebra. Here's your answer, 14 degrees. Okay, and maybe we'll go back to blue. Just a little kind of creature of habit, a little OCD maybe, who knows. But I like that answer's in blue. There it is, ladies and gentlemen, easy peasy. So the idea is, can we use that calculator, right? That's all. And so let's do the next one. That's it. So notice this, there's no special triangle when you use the calculator. There's no process. You just put it in that calculator and that's it. Because you might say, to me, you might say, hey, Mr. Judge, I like this idea where I say, hey, let theta, right? Let theta be inverse tangent. And then you say, oh, that means tangent theta will be what? Well, you found the calculator found the angle. The angle is 14 degrees. It's a 14-degree angle. So you don't have a 14-degree special triangle. You got 30, 60, 90. You got 45, 45, 90. So that's the idea I should say to you. There is no what? Special triangle here. So you don't go through the process. You just use your what? Calculator like they told you. That's all. So these are easier. You know, this is the exact questions because there is a special triangle. Right? And you go, how do I know the difference? Well, because they'll say in the instructions, use a calculator. And then you say, well, these values will be decimals. So, you know, that's kind of how I recognize it. So you go, oh, okay, I have to find again what? Inverse tangent. Your angle is a negative angle. Negative 0.2563 now. So in the TI calculator, we'll still say second inverse tangent. Now it's negative. Don't put subtraction. If you have a subtraction key and you use it, you'll get an error. Make sure it's the negative sign there. There it is. Negative 0.2563. Close that. Hit enter. Now that's a negative angle here. Negative 14 degrees. Okay, you guys okay with that? Easy peasy lemon squeezy? Okay, now let's do this here. Inverse tangent of what? 2.6178. So, second inverse tangent 2.6178. 178. Close that. And ladies and gentlemen, what's the angle now? That's 69 degrees. Is that true? All right, now they're going to give you that negative version. So you have inverse tangent, and you're going to have this value here. Let's see what it gives you. Negative 2.6178. Close that. And that's going to be now a negative what? Negative 69 degrees. So, ladies and gentlemen, there you go. This is how we use our what? Our TI calculators, okay? Well, this is how I use the TI. Maybe you guys have a different one, but so there it is. This is how we simply punch that in, and you know, it's very useful to punch things in like that. So now let's kind of focus on this so you guys know. You might say, Mr. Judge, why do we even care about these